Okay, we're continuing with more example problems where we make use of cofunction identities or the sum or difference identity for cosine. So, okay, use the identities for the cosine of a sum or difference to write each expression as a trigonometric function of theta alone. So this is about if you plug into a sum or difference of cosine, a quadrantal angle for one of the angles, it ends up simplifying to where you have just a trig function of an angle. So if we do so, cosine of 0 degrees minus theta, and so here's the cofunction identities, here's the sum or difference of cosine identities, and we know we have cosine of a plus b, cosine of a minus b. The sign in the middle is opposite of what's in the argument for the cosine. So this is cosine of a plus b, and then here you have a minus. Here it's cosine of a minus b. Here you have a plus, and then it's just out on the outside of the signs. It's cosine of the first angle times cosine of the second angle, and then plus or minus sine of the first angle times sine of the second angle. All right. So this is cosine of an angle minus an angle. So we've got cosine of 0 degrees, cosine of theta, and then plus sine of 0 degrees, sine of theta. All right, cosine of 0 we know is 1, sine of 0 we know is 0. So we're left with cosine theta. Well, yeah, I guess we could have, obviously that's what it is, right? Because cosine of 0 minus theta is just, well, I guess not obviously. This is cosine of minus theta, but cosine is an even function. So cosine of minus theta is that the even odd identities tell us that cosine of minus theta is cosine theta. Okay, now cosine of theta minus 180. That's another quadrantal angle. We've got, so cosine of theta, cosine of positive 180, because we're going to use the difference identity, plus, I mean, you could use the sum identity but use so cosine of a plus b and use b is equal to minus 180. You could do that. But okay, cosine of theta times cosine of 180 times sine of theta times sine of 180. Okay, 180 degrees, that's going to be, so cosine is going to be -1 there, and sine is going to be 0. So we've got minus cosine theta. Okay, cosine of 0 plus theta, well, that's obviously going to be cosine of theta, but we can write this out. We've got cosine of 0, cosine theta, and then minus sine of 0, sine of theta. This is 0, this is 1, so cosine theta. Okay, cosine theta, or cosine 180 degrees plus theta is cosine of 180, cosine theta, minus sine of 180, sine theta. Cosine of 180 is -1, sine of 180 is 0, so this is minus cosine theta. Okay, here we want to find cosine of s plus t and cosine of s minus t. Given that, so yeah, for each of these problems, we're going to do this. And so for the first problem, we're given that sine of s is 3/5 and sine of t is -12/13. And s is in quadrant 1 and t is in quadrant 3. Okay, so to do this, what we're going to do is we'll expand these out using the sum formula. So we've got cosine s, cosine t, minus sine of s, sine of t. Okay, and then we've got, so cosine of s minus t is cosine s, cosine t, plus sine of s, sine of t. And we've got sine of s and sine of t. We just need cosine of s and cosine of t. Now, how are we going to find these? Well, what we're going to do is, so, all right, S is in, we'll draw 2. So S is in quadrant 1. So we'll draw, just some random terminal side there. And then T is in quadrant 3. So we'll draw another random terminal side there. So, okay, this is S. This is T. Okay, now the definition of the trig functions, we make a triangle, right, with the perpendicular on the horizontal. And then we can use, okay, so sine of S is 3/5. So sine is opposite over hypotenuse. Okay, but then we don't know this. We'll say that's x. Sine of t is minus 12/13, so opposite over hypotenuse. So yes, this makes sense because we'll have, let's see, this will be 13 and minus 12 here, and we don't know this side. So we can use the Pythagorean theorem. We know y is going to be negative and x is going to be positive, but we can just use the Pythagorean theorem with positive numbers like side lengths of a triangle to get these values. So let's see, so all right, 25 minus 9 is 16. Square root of 16 is 4. So x is going to be equal to 4. Okay, y is going to be, so 13 squared, and then 12 squared is 144, minus 144 is 25. So y is going to be equal to 25. Well, negative 25. Okay, and so now we can get, so what is cosine of s? Cosine of s adjacent over hypotenuse is 4/5. What is sine of, or no, cosine of t is what we're missing. So cosine of t is adjacent over hypotenuse, so minus 25, wait, no, minus 5. I had to take the square root. Okay, minus 5/13. So there we go. So, all right, now cosine of s plus t, we just plug everything in and simplify. So cosine of s times cosine of t, okay, minus sine of s is 3/5 times sine of t, okay, so minus, all right, plus, that's 36/65. Yeah, okay, so minus 4/13 plus 36/65. (16/65). So cosine of s plus t is equal to 16/65. All right. Cosine of s minus t is, so cosine of s is, yeah, well, okay, it's going to be the same thing, just, yeah, it's going to be, you do minus 4/13 and then minus 36/65. Minus 56/65. Okay, same type of problem. We've got, so cosine s, it tells us s and t are both in quadrant 2, so let's just put this at some random angle. All right, there's S and there is T. Okay. All right, cosine S adjacent over hypotenuse, so that's minus 1/5. Sine of T opposite over hypotenuse. Okay, so now let's find these missing side lengths. 25 minus 1 squared, so that's 24. Square root of 24, so let's see. 6 times 4 is 24, so 2 root 6. All right, now here we've got 25 minus 9 is 16. Square root of 16 is 4, but we'll put minus 4. All right, so now we need, let's see, we need sine of S. And we can see that's going to be opposite over hypotenuse, so 2 root 6 over 5. And then we need cosine of T. And that's going to be adjacent over hypotenuse minus 4/5. Okay. So cosine of S plus T. All right. Cosine of S. Cosine of T. And then minus sine of S times sine of T. All right. So we have a common denominator of 25, so we can do, let's see, 4 minus, and then 2 times 3 is 6. 4 minus 6 root 6 over 25. And that is cosine of S plus T. All right, now cosine of S minus T is just going to be the same, same thing, just this will be plus. So we can write this as 6 root 6, or no, it would be 4 plus 6 root 6 divided by 25. Okay, same type of problem. S and T are in quadrant 1, so here's S, T. Okay, so all right, sine of S opposite over hypotenuse, sine of T opposite over hypotenuse. Okay, so 49 minus square root of 5 squared, that's 44. Square root of 44, 4 times 11, 2 root 11. Okay, now here we've got 64 minus 6. That's going to be square root of 58. I don't think there's anything we can do with that. No, so okay, square root of 58. All right, now we need cosine of S and cosine of T. So cosine of S is adjacent over hypotenuse. Cosine of T is adjacent over hypotenuse. So, all right. Cosine of S plus T is cosine S times cosine T. So we've got that's sine of S. So cosine S times cosine T minus sine of S times sine of T. So we've got, let's see, 58 times 11 is 638. So okay, and then 6 times 5 is 30. Okay, so 2 that is cosine of s plus t, and then cosine of s minus t is going to be similar. We'll just be subtracting adding these. So it'll just be 2 and there we go. Okay, verify that each equation is an identity. And then they give us a hint that cosine of 2x is equal to cosine of x plus x. All right, so, this is a cofunction pair, but we're not trying to solve for x. Like we could write this as, sine of minus x is equal to minus sine of x, and then we could, say minus x is equal to 90 minus this, but we're not trying to solve for x here. We're trying to verify this identity. So let's expand this out. So cosine of pi over 2 plus x is equal to, so cosine of pi over 2 cosine x minus sine of pi over 2 sine x. Cosine pi over 2 is 0, sine pi over 2 is 1, and so there you go. There, that validates or verifies the identity. Okay, so there's cosine 2x, so let's use that hint here. So that's cosine of x plus x, which we can write as, let's see, cosine x minus sine x sine x. I wish they didn't give us this hint. You should have been able to figure that out on your own, right? That's cosine squared of x minus sine squared of x. There you go. Okay, let's see. So we just saw that cosine 2x was equal to cosine squared x minus sine squared x. So let's do that. Cosine squared x minus sine squared x is equal to 1 minus 2 sine squared x. Now let's change cosine. Using the Pythagorean identity, we can write this as 1 minus sine squared x. Okay, that's cosine squared minus sine squared is equal to 1 minus 2 sine squared x. So that we get, simplifying, there you go. Okay, so here, let's go ahead and write cosine 2x as cosine squared x minus sine squared x. And then cotangent squared is cosine squared x over sine squared x. Okay. Plus 1. Now let's multiply this right side by sine squared x over sine squared x. And so what we get is cosine squared x minus sine squared x over cosine squared x plus sine squared x. But the denominator we know is 1. Cosine squared plus sine squared is 1. And there you go.